Hey, hi everyone. Good afternoon. Yeah, sure. No problem, jokes. No, you can fill it up when the link is shared. You can absolutely no problem on that. Okay. Hope I'm audible to everyone. Please let me know, friends. Perfect. And you're able to see the screen as well, right? Okay. Wonderful. So we'll begin in a minute. Okay. All right. So let us start the session, friends. And yeah, to begin with, we will do the revision every day. We will be doing the revision. Okay. So that these things are internalized into your brains. R programming, developed by Ross Ihaka and Robert Gentleman. It is a functional oriented programming language. It is developed for statistical computing. It is a single threaded software. It is an interactive programming language, and it is an interpreted. We basically have to use this interpreted at the start. So it's interpreted language, and it is interactive programming language used for statistical computing. And it is very easy to write because it's based on English, right? High level programming language. It's a high level program. So these are the bunch of features. Then we discussed about dynamic nature of programming in R, wherein the data types will automatically be assigned to your variable. So you just have to create the variable. You don't have to define or declare the variable. Right? All you have to do is assign a value to the variable using either equal to symbol or arrow symbol. left arrow or right arrow, where head of the arrow will always be the variable. It is pointing towards the variable. Tail is towards the value that you are trying to assign. Using this assignment operator, you will be assigning a value to the variable. Variable can be alphanumeric. It can start with dot, but it cannot start with number or any other character. It has to be only starting with letters. That's your alphabets. They start with only alphabets. And dot or underscore are the two special characters which are allowed. Apart from that, none of the special characters are allowed. Okay, one more point. In variables, when we talk about variables, in R, there are predefined variables. Okay, there are already a few variables which are predefined. Okay, as and how we proceed, we will come to learn about those variables also. And the new variables are very dynamic. You just create the variable, assign the value, and the data types are automatically assigned. Now, when you talk about data type, in R, we have integers, we have numeric values, this is nothing but double, we have character, we have complex, we have date, etc. Then data structures start with vectors. It's a one-dimensional data, and vectors will always have a single data type. And we have list which can be converted from vectors, and here you can have multiple data types. Then we have strings. Strings are non-numeric data. Okay, these are data structures which are non-numeric data structures. Right? So we have vectors. This is the default data type. Then we have list. Then we have strings. Then we have matrices. Now this is a two-dimensional data. It has rows and columns. Then we also have arrays, which is greater than 2 dimensions. And in R, we have factor type. This is a special data type, which is for categorical data. But it is a statistical computing tool, right? So it needs to have numeric values. So internally, this categorical data is interpreted on numeric scale called levels. Then we have data frames. Data frames is the default data abstraction for R programming, which can be interpreted as a table. The difference between a list and a table. Table has a two-dimensional. Okay, list can also have two-dimensional. Okay, can have. This is mandatory. When you have list, right, you have multiple objects in list, let's say vectors, then your vectors will be treated as a row. Each vector is treated as a one-dimensional value, right? It is treated as a single row with multiple columns in it. Whereas a data frame, which is your table in R, will have vectors treated as factors or variables. This is how your data frame is created. In a data frame, the vectors or the headers should have value. Right? They should have value. Cannot have a empty vector. Right. Next. After this, we discussed about operators. Here we discussed about assignment operator. We've already discussed equal to arrow symbols. Then we discussed about arithmetic operations. These are nothing but minus, plus, multiplication, division, right? Etc. No, multiplication I've already written. Power. floor division is also there, right? All those things will be there. Then we have logical operations, we have relational operations, right? Special operations like matrix multiplication and identity operation. These are all special operations that we have in R. Post this, we discussed about conditional statements. Conditional statements are nothing but your if statements. If or if else, or if else if, or we have nested if. These are all the various conditional statements, and these conditional statements will only give you a Boolean output. Boolean means it will either be true or false. And your if statement works with if true conditions. If true, you want to apply a task, do the task. Right? So that's conditional statement. Now, after the conditional statements, we proceeded further to discuss about loops. And in loops, we understood that there are pre-loops, post-loops. Do while is a pre-loop, for example. So you do the task and then get into the loop. Then you verify, right? So that's pre-loop and post-loop that we have. But yeah, finite loop and infinite loop is what we have to look at. Finite loop means it will check for condition in the loop for limited number of times. There will be some iteration, right? Whereas infinite loops only check for conditions. It will repeat the loop until the condition is satisfied. Then we have a repeat loop, right? Finite loop can be interpreted as a for loop and infinite is while loop. It doesn't mean that you cannot write a finite while loop. It's just it is interpreted like that, that the generic syntax can be treated like this. Then we have a repeat loop. We have switch function, right? In loops, we have switch function, which will take us to a specific value. Right, so this is something that we discussed. Then we further went ahead to discuss functions in R. With so many things, hope you are documenting everything. Taking notes. We discussed about functions. In functions, there are broadly two types. One is inbuilt, the other one is custom made or user defined. Custom built. The syntax of the custom built functions is define a name and use this keyword. This is the keyword which tells our interpreter that it is a custom function that you are trying to create, and it will be known as this name henceforth. Put a flower bracket and then fill your body inside this. Now you'll also have to look at the arguments that you're passing. Okay, there will be certain arguments that you need to pass, right? So those are also passed here. And when you're calling the function, you just call the function with those arguments that you're defining. Right? So these are your custom functions. Now, from the functions, we then discussed about packages. R is a functional oriented language, so a lot of functions can be developed, and these functions can be reused, right? So we have enhanced those custom functions applicability by converting them into packages. So our core community decided or decides on what all functions can be generalized, identify those functions, and then segregate those functions based on their characteristics, based on their applicability. Right? You group them. And in each group, you might have multiple functions. Along with these functions, you will be expecting to have documentations, and you will be also can expect to have sample data. Now all this is coupled together and given a name as package. This is nothing but a .zip file which will be loaded in your CRAN, centralized repository. And you're going to connect to the centralized repository to get this particular package. And in order to do that, you'll just have to execute this function, install.packages, and put the double quotes inside that bracket, and within the double quotes you're representing the package. Now by default it will be connecting to repository, checking for the relevant package, the latest one of course, downloading that into your system. It's a zip file, right? So you will extract that and then put it in our library as a location. Generally it is in the documents folder. By default it will create a location or a folder in documents, and that's where these libraries are getting stored, or that's where your package is getting stored. You can list out all the packages by saying library, or you can come to this option, packages option. If you click on this, it will show you all the packages that are available here. Yep, these are all the packages. It will also tell us the version at which the package is installed in your system. So this is the list of packages which we have. If you want to have a specific package, then you're going to first search here. Type the name of the package and search for the package. If it is already installed, if you are already installed the package, then it will show here when you are searching. Right? If you do not have the package installed, then there will be no result. Nothing will appear here. So in such case, you have to install. I've already mentioned install.packages is the command that you might want to run, or use this install button. This is something that we have learned, right? And when you click on this, there are two ways your installation can happen. One is from the centralized repository. That's your CRAN. The other one you can see here is the archived location. Archived location basically is offline mode. So for example, in your team or in your organization, there are a lot of people who are working. Okay. And let's say these teams are solving a lot of business problems using RProgramming. Okay. Now these custom functions can be saved into a tar file or a zip file and located in a specific folder. Right? Now those packages, those functions can be downloaded into your folder. Those functions can be loaded into your folder. So you're going to dump everything in a specific location, and you're going to point that specific location here. And this is how you are going to install the packages. You can have multiple packages installed at one go as well. There are 16,000 plus 16,500 around packages roughly available, and keep counting, right? We keep counting, it's increasing. So a lot of business problems are already solved. See, if you want to work with agricultural related scenarios, you can see this agri data is there. Right? So a lot of data sets are also available in R. And to look into those data sets, we say data and open and close bracket. Now this will list out the data sets that are available in R from the package called datasets. Right? But at the same time, we can also get the list of datasets which are available in these kind of packages. Different packages, each package will have its own sample data. Right? Majority of them have. Few of them don't have. Those will be designed to work on existing datasets. So somebody who has written the code, they might have used the existing dataset, so they did not add any datasets for practice purpose. We can use the existing datasets in such case. All you have to do is type data, open and close bracket, and enter. You get datasets available. And in order to get a dataset, all you have to do is, where is this here? Type in the dataset name. Yeah. Type in the dataset name like this. Right? You're saying data and open then close bracket and say Titanic. So you can see it says promise. It is creating an establishment, a connection establishment here. And whenever you execute any other command, it will load. Only then it will load. Similarly, we have pressure. This is also saying promise. And when you say view, it is going to load your dataset. Now, in order to learn about the data, you will see question mark, right? The documentation is available just a question mark away. Yeah, you'll have to do a question mark. All right, next. We have also seen how do we convert a data set which is in array format to a data frame format, because not all the data will be in data frame format, right? So we have understood using as dot command, we can convert our data, right? So this is typecasting. So just to demonstrate, we are taking a character data A. If you see structure, it says character. I'm converting that into numeric, is numeric. Is numeric is to verify. Is it numeric? No. But you can convert that into numeric by saying as numeric. Now, R is intelligent enough to understand that it cannot convert a non-numeric data into numeric format, right? So it is going to give you a warning message, and see if you say structure of B, it says numeric value, but the value doesn't exist. There's no value. It cannot interpret the red character data into numeric form, right? But if you have an array that can be that needs to be converted, then yeah, we can do it as data frame, as dot data dot frame, and that gives us the data frame here, right? And this is your data frame. Now, if you say structure, it is giving us the structure of the data frame. Okay, this is Titanic 1. Let me put Titanic 1 here and check. It's saying it's a data frame, and these are the factor data types that I have, except for frequency. All the others are factor data type. By default, it is interpreting the categorical data on numeric scale. Right? So this is your data set loading from inbuilt set of data. Now we'll come back to this, okay? We'll come back to all these calculations, but Let us try and understand visualizations. Okay, today's class we will try and visualize the data. Okay, then tomorrow we will be doing the calculations. Okay, let me close all this, not required. Yeah. So I will be using this inbuilt data set. Okay. Now I have categorical data here. Okay, a lot of categorical data is there. Let me go to this. Yeah. Now what is my data set here? It has class, sex, age, survived, and frequency. Right? Now, on this data set, you might want to come up with bar chart. A bar plot basically is to create bars. It represents data in form of bars. Right? So let us try and visualize this bar plot and then try to understand what we are doing here. So the bar plot is very simple. You just say English bar plot. I don't even have to type completely. Look at that. Now these packages that you're seeing, graphics, stats, right? These are inbuilt packages. The bar plot function is available in an inbuilt library or inbuilt package. And you see this global environments here. Under the global environment, you will have these packages listed. Except for this last one, everything else is an inbuilt libraries. That means as soon as you open your RStudio, these packages will be by default loaded. Right? You don't have to import these libraries specifically. Right. So this is about your bar plot here. Now bar plot, when I do, right, it is trying to give us visualization of data on bar format. Each value will be taken in a bar format. Now I have data which is categorical in nature, but I know frequency is something that I can consider. Right? So in total, I have 32 rows. I will come up with bar plot. Now, how do I access the data? Titanic 1 is your data frame. And it has 5 columns. Now, how do I represent the data? Or how do I access the data here so that the visualization is done? So in R, you always have to represent table name, dollar column name, or variable name. This dollar is signifying that it is a subset of this. Right? So you say bar plot, your command, and then you put this table name, dollar column name inside there. If you directly represent column name, then R will not understand because that column name is not defined here in the environment pane. This is the syntax, friends. Any command that you do, right? By default in R, this is the syntax. Command, the table name, dollar, variable name or column name. Now I take Titanic as a table name. So this is my command. Bar plot is my command. Inside that, I want to talk about Titanic. You can see here it will prompt us with the table names, which is starting with that characters which you are printing there. So I have bar plot, Titanic. But Titanic is entire table. It has 5 columns, right? If I execute this, it says height must be a vector or a matrix, right? Bar plot represents each value in the data as a bar, right? So let us do this. Titanic 1. As soon as you put dollar, it will prompt on what are those column values that you want to choose. So you're saying class X age survived frequency or saying frequency. Bar plot Titanic $1 frequency. And now you execute it. You see here on the plots section, you get this visualization, right? And you can zoom it out. If you click on zoom, it will come out and then you can maximize it. You can see each data point is represented as a bar, right? Where height of the bar is talking about the value. Height of the bar is talking about the numeric value of that particular feature, right? You take any data, you can create a random data. Let me create a random data here and plot it. So let's say the data is, I'll create a vector 10, 20, 15, 50, right? Or 30. So creating this data, right? And very simply say bar plot of data. That's it. Automatically, it will read the values. Remember, bar plot is representing the values in bar format. The height of the bar is what you get represented here, right? Or based on these numeric values. So I'll represent this. This is data. Created the data and then simply say bar plot. That's your bar plot. Yep. Now you want to come up with enhancements to this visualization. It's not giving us any information, right? It is fine. Bar plot is fine, but it doesn't give me any information. So in order to understand various, right, in order to give various details, right, to this, you might want to have a lot of enhancements being put there. Okay, so let's take question mark of bar plot. You just take question mark of bar plot. When you do this, a lot of documentation is available, friends, for your experimentation. Creates a bar plot. This is the syntax. Look at that. You can create so many, right, different options. You can take different options. Each option is explained here. Height is nothing but the height of your vector data. Width is also something that you can define. Space between them, names. Right? Names will basically give us the name to each bar. So probably I will, let's say, call it as X. And I'll say, this is some names, okay? Red, blue, the green, black, white. 5 values are there, right? So I'm defining names to each of these values. I can put that. I'm labeling them. I can also add value to the x-axis, y-axis as well. I can put colors to the bars. So all these are the different, right, options that we have. Horizontal is equals to false, which basically, right, means you're not putting the values horizontally. If you say true, then the bars will be placed horizontally. Right now it is vertical. That means false. COL is the color. Right? Border can also be given. X lab, Y lab, X limit, Y limit. These are all your limits that you are putting and the labels that you are giving for X axis and Y axis. Right? So many different features are there. I mean, arguments are there that you can play around with. So let me show you bar plot with, let's say, data, comma. I want to say width is equals to 1, so probably 2. Then I want to say names dot argument will be x. I want to put x there. Then you want to give label, x axis label. You want to say color. This string you have to put. Then y lab, y label, y axis label, you want to put something there. You can see all these are there here. Okay. Y axis label, you might want to say purchases. How many times these colors are purchased? I have to put this in the quotes, in the quotation. Right, so I will execute this. X is not found. I did not execute this. Okay. Look at that. So I get color on x-axis, purchases on y-axis. I'm also getting labels to these colors, right? Different colors are there. You can also put colors here as an argument, right? And you can choose, let's say, blue. By default, it will be gray color. You can come up with blue color visualizations or red color visualizations. You can also, right, try and map it with various colors. Yeah, so you can also define various colors to it by giving a color combination. Let's say I will try and create colors here. Okay, I'll add one more column. Colors. You can see here when I typed, right, these are already there. This is a function, right? So I'm basically giving a different name here. Yeah, I'm giving a different name. Okay. You can give any name. You can use the same name also. Let's, there's no confusion. We'll give colors. I need to give the same color, right? So let me give the color. Red color. I'll copy it. This is the same data. I'm just putting colors. Or even if you don't want to put colors, you can just say X here. Let's say colors is not defined, only X is there. You put colors there. Right? So if your data is something else, then you might want to give colors there and mark those values. Yeah? This is your bar chart. All right, next. This is one of the, okay, 1 second. Give me a minute, please. Okay, give me a second.
Yeah. So we are basically we covered bar plot. Next, we have various other visualizations. Okay, this is bar plot is one such visualization that we can come up with. Then how about coming up with, let's say, a line diagram? Same data, can I try and come up with a line diagram here? Right, let's see that. So this is bar plot. Now let's see line chart. I'll basically data, okay? So I already have X here, right? X data, in fact, that is what we need. To chart, we just have to say plot. Plot of your data. Okay, plot of data. Let's do this. You're getting the data points plotted on index. Now, any visualization will by default take two values, x-axis values and y-axis values. You've already plotted y-axis values, right? You are giving y-axis values. So the x-axis will be sequential in nature. Now on this, I want to come up with a line chart. So all I do is take plot, put data, comma, you're putting type is equal to O. When you put this, you get a line chart. Now again, you might want to know what all options I can have with plot. So generic X and Y plotting is what we're talking about here. These are all the various arguments. O means over plotted. L means lines, of course, you get single lines. Over plotted basically is like connecting the lines. Okay, that's your line chart. You can, of course, add various other values here. These are all the different options that you can play around with. Now we are doing O because we are interested in getting the line chart, right? So very simply put, line chart here. Now how about giving color to the line chart? There is various other arguments that we can pass, right? So let's give colors to the line chart. Just like previously, you'll say plot data comma type is equals to O. I'm just typing the same. Then to give the color, you put color, right? And say equal to, probably you'll give blue color. And then you might also want to add x-axis, y-axis labels, which are already there by default there, but you want to change. X label is basically saying colors, and some index, right? So you can say quantity. And Y label, you want to put some other value, your wish. Right? We already have data. Let's say colors. I want to put colors. You get see that the visualization is changing now. Yeah. So this way you can come up with colors, but you can also have additional information here on the same data. I mean, I'll take, if I change this to X, see what happens. It doesn't work. Why? Because X here is non-numeric data. X is non-numeric data, right? So it will not work out. Okay, so we need to have numeric data for line chart. Probably might take frequency, then it will work. Okay, remember that. Now let's say I will also take D1 and D2. Let's say D1 is your data. D2, you are coming up with some other numbers, probably 100, not 100, but let's say 15, 30, 50, 20, and let's say 80. Same 5 numbers. So I have D1 and D2. So now see what I'll do. I'll basically take D1 here. Okay, same visualization, just that I'm changing D1. Okay, I'll plot D1. This will give you a line chart, right? First, it will give you a line chart. Okay, I've not executed this, sorry. And then we'll say D1. I got it. Now, in the same visualization, you might want to pass in the plot. You might want to add another one. So you're going to say lines, and then you're going to say D2. Right? And you have to say type equal to 0. And to make sure that there is a difference, let's put a different color here. Look at that. Because first my D1 is printed, so axis is fixed. Hence, you see that red line is cut there. If I say D2 here and then say D1, then it will be right coming inside the graph, because now D1, D2 is printed first, executed first, so the axis is created like that, right? So this is how we can create line charts. So we discussed bar chart, we discussed line chart. Okay. Now all these visualizations are readily available in this graphics library. You can see all these are different options that you have in your graphics library. Yeah. What did we do? We did plot. We'll also do pie chart now. We did plot, right? Then we also did bar chart. Here we see bar plot there, right? So like this, there are various other visualizations which are available. You can play around with them. Let's do pie chart now. One of the most popular charts is pie charts, and it is considered to be the least preferred chart in visualization concepts. Yeah, if you talk about visualization concepts, pie chart is considered to be the least preferred. For bar plot, we used a function called bar plot itself. For line chart, we used plot and of course lines. And for pie chart, we use pie function. Pie. Yeah. And let's try and do this. So I will take that data. And of course, X. There are two things, right? Because let me show you. if I say pie chart, it's all very easy. You say pie data. You try and come up with this. This is what you are going to get. Yeah, pie chart, this is what you get. But how about also adding the labels, because it is sequential values that it is taking, right? Your data that you have is having a sequential data. If I say data, you can see that it is 10, 20, 15, 25, 50, 25, right? So those are the values that it is showing here. Area is occupied based on these values that we have in data section. But how about labeling them also? So like bar chart, we will put X here. We can say labels is equals to X, or by default it will take labels as X here. And this is what you get. You're putting names there. You do question mark of pi, of course, and you get labels is equals to X. That's what we passed. Then we have edges, radius, clockwise directions, right? Various other options that we can put here. Right? Colors. We can play around with the colors and right various other things here. We'll try to play around with the color. So I'll use the same function pi data comma X. Labels is equals to X. Okay. Next. Color is equals to, how about passing date X only? I can pass X only, right? Look at that. You can also pass default colors. I have rainbow colors. Okay? But rainbow colors, how many colors you want to use in rainbow colors? Argument n is missing in rainbow. So you have to pass 5. Because you have 5 data points, right? So you're using 5 values there in the rainbow colors. Now we can also add a lot of details, further details here. How about adding percentages? Now each of this is distributed by considering the percentages here, right? So let us do that percentage calculations. So I'll say pi data comma X comma, you might want to continue on top of the colors. Let's use the same colors. I'll say colors is equals to rainbow colors. 5 colors are there, comma. Now we want to look at, let's say, the percentage, right? Yeah. So let's put this percentage here. Very simple. Rather than X, you put a keyword here. X is nothing but labels, right? Labels will be equal to, what is that we want to show? Pi percentage. Now what is this pi percentage? How do you get this pi percentage? You will be passing this pi percent by adding those values here, right? So let's say percentage is equals to, you will be calculating the percentage here. How do you calculate the percentage? The values are there in data, right? Yeah, you have data. So divide data by sum of the data. Now what will this be? If you do this, what you will get? proportions. You need to multiply this with 100. That gives you percentage. Just multiply with 100 and take this calculation, you get percentage. Yep. Now, let us take this percentage to the visualization. So I'll just put %. So remove that X here using percentage. Right? You might also want to add a lot of things. We'll first discuss this and then we'll go to the legends. Okay, I have to execute this and then come here. Now what is happening? The numbers are too big there, right? So let us round it off. So I'll round it off to probably 2 decimal points. Round it off to 2 decimal points. So this is your pie chart. You might also want to add legends for any visualizations, right, that you are doing here. You might want to add legends. Yep. So that legend can be executed like this. You're adding it externally. Where do you want to put it? So if you do question mark of legend, you will see that details. Add legends to plots. Right? You have a locator as well. Where do you want to put this legend? If you go down all the way, right, you see these examples. You can take these examples and start off. Okay, so as and how you practice these things, you will understand, right, how you can play around with these legends. Legends with the titles at different locations. These are different locations. Where do I want to put this legend? In my visualization, probably I want to put it on this side, right top, right? So top right would be my feature. So I'll say in the double quotes, top right. And what should be there in the legend? What is that you want to put? You might want to put X there. Right? But yeah, it will not read like this. Why is it not reading like this? It's a list, right? I removed the question mark. Yeah, got it. Yeah. I want to also see that everything is properly given. So I will change the size here. CAX is basically probably I'll say point, a small number. Yeah, you can see it's very small number that we are putting there, right? So this is how we can add these legends. On top of the legends also, you can add further more details here. Let's say I would put fill this colors, fill the legends with the colors. What did we do? We say rainbow 5, right? So we'll take the same here. You want to fill this legend also with these colors. So it will also add those details. Right? So this way you can add legends to your data. This is a simple pie chart. Yep. So we come up with a pie chart. We can basically come up with visualizations with different colors. We can add percentages. We can add legends. Now in R, there's one interesting pie chart that you might want to also see. This is a 3D diagram pie chart. What you have seen now is a two-dimensional diagram, right? We can also come up with a three-dimensional pie chart, 3D pie. Okay, so we simply say pie 3D. This is the the 3D pie chart that you can come up with. It looks a little beautiful, but this pie 3D is not available in your default library called graphics. You need to have a library called as Plotrix. So what do? We check whether the library is available with us or not. Plotrix. You can see this library is already there. I click on that, it says various plotting functions. These are all the different plotting functions that we can see. And if I come directly to P, these are my visualizations, and you can see Pie 3D. Pie 3D is a library or a function which is available inside the Plotrix library. And this is the syntax. But if I say question mark directly, it will not show you now. Why? Because this library, Plotrix, is not loaded. It's installed, but I have to call that, right? In order to invoke any package, we say library of Plotrix. You have to give the package name inside library. Now, if you say Pie 3D, you'll get the documentation here, right? I might be there here or this location. I'll say question mark of Pie 3D. It is redirecting me to come up with this 3D chart. So I will be using the same data set. I have data and colors, right? X. So I will say Pie 3D, and I will say data comma X. This is my labels. And then you might want to just see error, non-numeric argument. Okay. Why is this coming? Pie 3D labels. Okay, is it treating this as something else? Labels is equals to X. Okay, now let's see. Yeah, so by default, if I say X is treating something else. This is your 3D graph. Now you can also split this. I mean, this pie chart can be split. So there is one interesting function that you can try along with this, that is exploding. Explode. How far you want to put this? Let's say I want to put it at 0.2 distance. Look at that. The pie chart is exploded now. If you reduce that, it will be a little less. Let's say 0.1. If I put it at 0.1, they will get, the pieces will get a little closer. Right? So this is 3D pie chart. Okay, next we will discuss about another visualization called as dot chart, and then we'll also look at histogram. Okay, but before that, let me take your questions. Is there any difference between bar? Of course, all these are functions, right, Jagdish? Each function is different. Each of that gives you a different visualization. We have done bar plot. We will be doing histogram. ggplot is a package inside which you will have a lot of options. Okay, each of this is different, Jagdish. I cannot elaborate everything. As and how we are proceeding, we are discussing each of that. You'll come across histogram now. In future, we'll also look into ggplot. ggplot is a separate entity. We'll discuss that as a separate entity. How to merge data frames? We will cover that also, Srinu. Merge is a function that we can do. R-bind, C-bind is also there. We can do those things. We'll do that. Can we read from, yes, we do read from JSON format as well. We can read the data from XML as well. Yeah, we hold on, guys. These are all your questions. We will be covering it. Okay, don't worry. We have not gone to that, right? That particular location. I mean, those things will be covered. Yeah. XML, CSV, we have done. Excel will be the next. Then we will also see JSON. We'll also see XML. Yeah, we'll cover them. What is Tibble? I'm not sure, Anand, what you're asking. I have no clue about what is Tibble. Okay. Yeah. All right. I see no more questions here. Not many questions. We will take a break now. It's 3:10. It's almost 3:09, 3:10. We'll connect back at 3:10. Now, how many of you have actually covered social media quiz? Let's see. Yesterday's quiz, how many people have actually covered, attempted? Oh, okay, very good. 200. Day 6. 75. Not good. Guys, what's happening? Are you not enjoying this? You have to, right? Try and apply, attempt the quiz. Very bad. LinkedIn is your professional network, and here it is very bad. Participate. You need to be active, friends. If you are not active on social media, you'll not be able to get a good opportunities. Today we are living in digital platforms. Okay, HR analytics, workforce analytics, people analytics is a big thing now. It's estimated to have around 35 billion, right? Estimation by 2025, if I'm correct. I forgot the numbers, but forecasting has been done. It is like going up like this. The arrow is going up like this. That means a lot of analytics will be applied on your profiles, recruitment. A lot of people here probably are faculty, right? A lot of them are faculty here. Assuming, whatever the profession you are. Let's say I'll take your profession as faculty. You're trying to apply for an upgraded job. You're learning, upskilling yourself. You're trying to get into a better job. You're preparing your resume and you're sharing it with a recruiter, an organization. You're submitting it here. Now here HR will read this, but do you think they will blindly trust whatever you have written? Don't you think these people will evaluate your profile? You will say that, hey, I worked on these projects. My current profession is this, and I worked on these projects. Where is the proof? Where is the proof that you have worked on these projects? How should I, if I'm HR, how should I trust your resume? You need to be active on social media. Because social media is something which you cannot hide or you cannot fake anything there. So HR people are referring to your digital platforms. And if you are not active on social media, then trust me, you will lose opportunities. Your profile will not be shortlisted in the first place. Forget about getting a call. Clearing the interview is the next step. Your profile will, at the first stage, is not getting selected. You have to be active on social media. For students, you have to say don't be active because they have to prepare, they have to study. But for you, working professionals, you have to be active on social media. Facebook is something that recruiters look, and LinkedIn is the other professional network that you have to be active on. These are the two primary social media active channels where you have to be active. Right? Connect to all the relevant people. Connect with me. Connect with InnoDataTix folks. Connect with other organizations which are in analytics space. If that is your next move, develop your network in that area so that when I look into your profile as a HR, I see some relevant stuff there on your wall. That way I can get at least some trust saying that, okay, this person's profile is mapping to the social media. That means he is a genuine guy. That is the reason why we are pushing you. I daily tell you to act on social media. You have to take the quiz, pass it on onto your wall so that other people take it. So that what happens is over a period of time, when I come back to your wall and see, your wall will have all these kind of relevant stuff, right? Not just connecting, be active, share relevant information on your wall as well. That's how you're going to build up your profile, right? So take this up, take this up. So we will connect in 10 minutes. In the meantime, make sure you are connecting to the social media channels. It's 3:15 now. We'll connect in 10 minutes. Okay, this is break. All right, friends. So I still see no improvement. Very bad. All right, fine. Let's move on. No, Anand, probably not today. We have to load the data set, right? So we will also have to look at loading the data. Yeah, and then we will also have to look at various statistical understanding. So we will do that. We are still in the preliminary stages, as probably in this week we will cover. So if I show you all that. So the mind map has all those things, right? We are right now discussing about univariate visualizations, and there are so many different visualizations that we can come up with. We are trying to look at few, right, mandatory visualizations that we generally do on daily basis, right? Then we also have to discuss about what are these things, right? Then how do we handle all these, right? So when we load the data set, then we will talk about them. Yeah. All right. So let's come here. So we have discussed about bar plot. We discussed about pie chart. We discussed about 3D pie. We've also discussed about line chart. Now let us try and understand a visualization called as a dot chart, and then we'll look into histogram. Okay. Let's say I have a huge data. Okay. Let's say I have a huge data. Okay. A very big data set. Let's look into some data set which can give us huge data. I think pressure is already, no, pressure is very small. Okay, Iris data set. Iris is having 150 records. This is a very, very famous data set. Okay, we are loading this data set. All right. And if you want to see the data, this is your data set. Yeah. So you have 150 records and we have 3 species. This is a flower data. Iris is a species, flower species. You might want to see this purple image, right? You see this? Okay, let me show you the images here. Yeah, this is your iris flower. Okay, so it has 3 different species in it. Okay, this is the inbuilt data set that is available in R, which is 150 records data. Do a question mark and you will get the details. Edgar's Anderson's iris data. Okay, it has 50 flowers from each species of iris, and these are the 3 species that we have: setosa, versicolor, and virginica. Right? So I have 3 different data sets, 3 different species. Let's say I'll come up with bar plot on iris dollar species length. If I put that, Look at it. 150 records, right? It's very, very clumsy like that. It's showing very clumsy. Now, how about coming up with better visualization here? I want to understand more details about this particular column, which is sepal length. If you look into this data set, iris data set, it says sepal length, sepal width, petal length, and petal width. These are basically talking about 3 species that we have. Okay. So I'm just trying to see each data point in sepal length column in a bar visualization. If you do that, it is not really good. You will not be able to get anything there. Right? Not much information is available here. Why? Because a lot of ink is wasted in the space, so it is too clumsy. Now you might also want to try and understand the information using dot chart. This is another visualization that we have. Dot chart. Sorry about the background noise. So in the dot chart, I will put iris. And I'll say dollar the sepal length, the same data that I have used. If you see, the visualization is a little changed here. Right? There, each data point in bar plot, each data point is represented using a bar, a line. Whereas here, we are using a dot to represent that same data point. Bar plot by default plots the heights of the bar. That means on y-axis your data will be plotted. In dot chart it will be on x-axis. I have 150 values, right? You can easily see the spread of the data here from here till 8. So you can say that minimum value is 4.3, 4.4. So the spread of the data is from 4.3 to 8. And you can see that only one value is there, which is the minimum 4.3. And 8 is only one data point. Right? So this way we can get much more details about your data when you're plotting this instead of bar chart. Can you tell what is the minimum here? Can you tell what is the maximum? We will not be able to, right? Whereas in the dot chart, you will be able to do that. Just like other visualizations, here we will be putting dot chart, iris, dollar, the first one, right? And if you see dot chart, yeah, you get this details. This is your dot chart. You have labels, you can group the data, you can color the data. G colors are there, L colors are there. So different options are there. Right? Colors to be used for points and labels. So let's try that. What happens here? If I take the same function and I put color is equal to, it's not COL anymore, it is color, full form. I will say blue. Let's see what happens. So the data points are plotted in blue color. Right? So on and so forth, you can also change the shape of those things. Plotting characters can be changed. Right? So you can play around with these visualizations here. This is generally used when you have a huge amount of data, a univariate data, but you have a huge amount of data which is not properly visualized in bar chart. Generally, we go with bar chart. But if you're not able to get much details in bar chart, then we use this dot chart. Right? So this is one of the visualizations. Now, how about discretizing the data? Discretizing the data basically means grouping the data and then plotting the visualizations. So that is done on histograms. Yeah, we'll be doing that in histograms. What does a histogram actually mean? What do you mean by histogram? Histograms are basically a visualization techniques which represents frequencies. They are known for representing the frequencies of the data. Right? So what happens is your entire data is broken down into bins. Bins, or we call them as levels, or we call them as intervals or buckets. So we are splitting that entire data into certain intervals, equal sized intervals, okay? And then we plot or we count how many values fall in here. So for example, in our iris data set, I have 150 records, right? Total number of observations is 150, right? My sepal length from the dot chart, we have seen that the values range from 4.3 to 8. That's the range, right? So when you're trying to visualize sepal length using histogram, this range is broken down into bins. Equal sized bins will be created. And in each bin, how many values are plotted is, how many values are falling is plotted on y-axis. For example, out of 150, there are 10 values which are falling between this bin, probably 4.3 to 5. Or 5.3, some intervals, right? So this is basically how you are plotting your huge amount of data again into histograms. Now this is similar to bar chart, very similar to bar chart, but what is happening here is in bar chart you are taking each value and then the magnitude of that value is plotted in the heights. Whereas in the histogram, we are taking the frequency and plotting that in the heights. Right? So let me show you that. I'll show both bar plots as well as histograms. Bar plot is something that we have already done. Let me come up with that again. Bar plot of iris, dollar, sepal. This is the bar plot. We did dot chart, which gives us some more information rather than bar plot. Now for histogram, the function that we do is hist. Here also I will say iris, dollar, sepal. Just passing the data, nothing else. Then I get this histogram. Right, you can see that the data has split into 5 units. So you're taking the entire data into bins size of 5 units. So 5 values are plotted on y-axis. 4.5 to 5, there are more than 25. Right? So on and so forth, it is plotting the frequency of this particular data. Frequency on y-axis and the input name on x-axis. We can further pass the arguments, but again, do a question mark of hist and you get details. Histograms, the generic function hist computes a histogram of a given data plots. If plot is equals to true, the resulting object of class histogram is plotted by default.
चल
Yeah. Okay, let me see.
है ना लैब के उठा जा रिलोड करो आ रिलोड लैब से
Right. So we are basically looking at. Sorry. Okay. So we have histogram, which is basically capturing these details. We're breaking the entire information into bits, right? And you can come up with these different options, right? And you can play around with this. Frequencies can also be there. Probability can also be there, right? Density. If you say density, it will give you a density plot, right? Color. Let's change the color, and we can also put borders to these visualizations. So I'll say histogram, iris, dollar, simple n, comma, color is equals to, let's say, blue. Right? We are saying color is equals to blue. You can also put border. Border basically is the color of the border, right? When you create the borders, blue is there. Let's put red color borders. Now, if you see very simple diagram here, the bars, each height is put it in the blue color, and the borders are put in the red color, right? So this is a simple visualization. You can also give various other values as well. You can also put x-axis label, y-axis label, x limits, y limits, right? And if I say density, I'll say histogram, iris, dollar, simple length, I'll put color is equals to blue, and let's say density. Right? So if you see here, density is also given. The density of shading lines in lines per inch. The default value is null, meaning that no shading lines are drawn. Any non-positive values of density can be passed. So let's say 1. Let's see what happens. So those are lines which are given there. Densities, right? So this way we can pass various arguments like this: angle, borders, main, plot, labels. And if you come down here, we get, yeah, these are the various examples that we have. I'm just trying to find out if I can have any specific visualization. Okay, breaks is something that probably we might have to see. I'll show you the breaks option. And anything. Okay, no. Okay, fine. So we'll put breaks. Let's say 5. So what did it do? 1, 2, 3, 4, 5. It has 5 breaks. If I say 9, it gives you 9 breaks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So it is splitting into 9. 1, 2, 3, 4, right? Like that. So it is breaking the number of values. Let's say 15. So bins will become smaller. You're splitting your data into smaller pieces. That's your breaks. You can decide how many breaks you want. By default, it is 0.5 in this particular data. So this is about histogram, friends. Now, histogram will also talk about various additional things like distribution of the data, exceptional cases, right? What is the flow? Basically, it decides or it explains that. And based on the number of splits that you do, the shape can also vary. If you see, for example, here, what is the shape of the distribution? If you're trying to draw like this, then you can see it is like this, right? By default, it is like this. You can see that it is going down like this. So there is a difference in the shape, right? Now, if I split this into further more number of splits, you can easily see that appropriate shape there. But be careful on deciding on how many bins you would be creating on the data. More number of bins, it becomes a bar chart, right? Very less number of bins, you'll not get many details from that, right? Breakup is not available. So this is something that we need to carefully observe. And then appropriately decide on how many bins would give us the right representation of the data. Right? So this is your histogram. All right. So if you look into the session, basically today we are focused primarily on graphical representations. Now I can look at the data, the numbers, but looking at the data from visual perspective will actually reveal a lot of information. Now we have used the visualization techniques, which are the default visualization techniques that we do on a regular basis. Okay, started with bar plot, then line chart, then we also looked into pie chart and variation of pie 3D pie. Then we looked into dot chart. Let's not put capital, we'll use a small case letters only. Dot chart. Then we looked into histogram. Each of these visualization will speak about the data in its own way. It reveals some of the other information. And remember, a picture speaks 1,000 words, right? So if I show you the iris dataset like this and ask you about sepal length column, you'll not be able to speak anything about it, right? You'll say that, okay, it is decimal values and I see the values are somewhere around 5, 6, 4, right? But you'll not be able to talk about many details. But when you're looking at the data like this in a visual representation, you will be able to derive a lot of insights, and each visualization will have, as I said, its own way to tell the stories. Right? And on top of that, we have question mark documentation for each function in order to enhance the visualization and add a lot of details to this visualization. And what are the packages that we were looking at? What is a package from which we have actually used all these functions? Yeah. Nobody observed, is it? What is the package name here? Graphics. And this graphics package is available directly under your environment. If you see, click global environment, you see graphics is inbuilt readily available package. You don't have to install and load that every time. It is automatically loaded. For 3D graph, we used a additional library, a new library, an enhanced library, and that package is Plotrix. Okay, but graphics is what you have to focus on, because this is the package which gives you all the foundational visualizations that you require. Anything additional is add-on. All right. So with that, we will conclude for the day, and let me take up your questions. Dot chart. Okay, I'll explain. Let me take up another questions if we have. Good. Very good, Sridevi. Yeah. Ah, wonderful, Pravalika. Oh, Varalakshmi also. Good. You have to create a Lakshmi Preeti. You cannot say I don't have. You're living in digital world, isn't it? You have to create your LinkedIn profile. Keep updating it. Facebook is a secondary option. LinkedIn is the primary option. So have LinkedIn option. Both are important. Okay. Very good. Very good. Okay. Visham City dot chart is just like your bar chart. Okay. There's nothing different apart from the way it is shown. This is bar plot. In bar plot, each data point that you're taking is represented as a bar. Okay. Whereas in dot chart, the same data is represented in dots. So here your value X is plotted on Y axis. The height of the bar is decided by this data that you are trying to feed in. This is 1, 2, 3, 4, so on and so forth. For dot chart, the visualization will be a little different. Rather than this height, this values that you're seeing, the X values, are plotted on X axis. Your data is plotted on X axis, okay? And then 1, first value, second value, those are plotted based on your X value. So each value is plotted like this. So the representation here is in bar format. Here it is in dot format. That's it. Okay, nothing much to explore there in bar chart. Look at this. This is your bar chart. So your data is plotted on y-axis. On x-axis, it is just an index number. 150 bars will be there. Sequentially, it is arranged. This is your bar chart. Now in dot chart, that y-axis is plotted on x-axis. The values are there on x-axis, right? And your numbers are plotted here. I mean, first, second, third, fourth, fifth, right? In height-wise, you can see the values are plotted. And each value you're seeing here is representing the value of the x-axis. Okay, so not much different. It's just the way you look at the data is altered a little. Which link, Murthy? Are you talking about the attendance link? Then it is there. So your data is plotted on y-axis. On x-axis, it is just an index number. 150 bars will be there. Sequentially, it is arranged. This is your bar chart. Now in dot chart, that okay, I'm able to get this. It's just an argument, is names. You might want to try out. Experiment Venkat Kali Prasad. Pass a value and see what it is giving. You have to figure out a lot of things. It's an ocean out there, right? You have to explore carefully on each and everything daily. Daily, some of the other things we'll be learning. So explore. Do a question mark of bar plot. Read about it. Take some inbuilt data set. You have so many inbuilt data sets. Pass arguments and see what it is doing. That's how you learn. Yep. All right. So with that, let me conclude for the day. And tomorrow we will be discussing further about box plot, which is very, very important. And then we will move from there to loading of the data. And then we will try and understand how do we do data analysis on the data and what all various processing that we can apply, processing techniques we can apply on the data. So that would be from tomorrow onwards. All right, guys. All right, friends. Thank you so much. Have a wonderful evening ahead. Take care. And do not forget to work on social media. Okay. Enhance your social media profile. That's very, very important. Thank you all.